Hi, it's Carly McAvoy. Today I'm looking at the graph of a quadratic equation. In my picture, I have a parabola that is opening up, and it shows several points on the graph, which we will talk about as we progress through the video. First of all, when you talk about the domain of a function, in the case of a quadratic function, the domain is always going to be all the real numbers, and that is negative infinity up to positive infinity. There's no limitation on what x value we can use here. So to write that in interval notation, it's negative infinity to infinity with parentheses on either end of that expression. Then if we want to talk about the range, well, the range are all the y values with a domain of the x values, the range is the y values, and so we can't have anything that is less than negative 12.25 because we can see at the very bottom of our vertex we have 1 comma negative 12.25, the y value being negative 12.25. So then we would say the range are all values greater than or equal to negative 2.25. And there's different ways to write that. I'm just writing in a very informal way right there to show you that our y values, and as they go down, are not infinite. The vertex is that very lowest point of a graph when it opens up. And so our vertex is given on the graph as 1, negative 12.25. And so since our graph is opening up, we can see that this is the minimum value of that graph. So in this case, we would say it opens up, so it's a minimum. If it was to open down like an umbrella, then will be a maximum would be our vertex. So it depends on whether it opens up or down, whether you're dealing with a max or a min. Also noted on this graph is the y-intercept, and the y-intercept is where the graph crosses the y-axis, and that is what if x value is 0, what will we have? And that would be negative 12. And so 0, negative 12 is our y-intercept. X-intercept, if they exist. Well, it's possible that we would have a graph that was opening up but didn't start until above the x-axis, for instance, and there wouldn't be any intercepts. Or we could have a graph that fell right on the x-axis and have one intercept. But in this case, in our picture, you can see that our graph crosses the x-axis in two places, at negative 6 and positive 8. So we have two different x-intercepts there. Does this function pass the vertical line test? Vertical line test just says if you put a vertical line anywhere on your graph, does it touch the graph in just one place? If it's going to be a function, it has to touch in only one place. And if you were to run a line across here, you can even think of the vertical lines of our coordinate system. Those each touch our graph in exactly one place. So it passes the vertical line test because it only touches once for any vertical line. And then the line of symmetry is where is the reflection point across this function, this parabola? And you can see that if I were to draw a line at 1, that where the x coordinate of the vertex is, that line going up would cut that sort of directly in half. And you can look at that if from 1, we have a vertical or x-intercept that is 7 points to the right, and from 1, if we go 7 points to the left, we have our other x-intercept. So everything is reflexive around that line of symmetry, which is x equals 1. All right, that's it for today. Have a fantastic time, and we'll see you next time.